In this example, we're going to take a look at the concept of a random variable and then also learn how to create a probability distribution for that random variable. And then I'll also review all of the vocabulary words and basic characteristics of a probability distribution in this example. So we're going to go ahead and assume that male births and female births are equally likely. So there is a 50% chance that when a woman is pregnant, that she's going to give birth to either a male or a female. They're equally likely. So in this situation, we want to consider two births. What are the genders of two births? And therefore, we're going to identify our random variable x as the number of females in those two births. So again, the random variable in this example, x, okay? The reason why it is a random variable, so I'll write down here is a random variable, is because it's a numerical value that depends on chance, okay? So the number of females that you get in two births, it's going to be a numerical value, and whatever number it is, it also is completely up to chance, okay? So for example, what I mean by that is, so for example, right, in two births, okay, a parent could have a boy first and then a girl. So in this example, the number of female is one, okay? Or a parent can have a girl and then a girl. So then here in two births, there are two females. Or a parent or a set of parents could have a boy and then another boy. And so here, this would result in having zero females in two births. So we can see here that the numbers 1, 2, and 0, okay, are numerical, and they occur by random chance. So this particular random variable is also what we call discrete. And the reason why it's discrete is because, so I'll write down here, x is also a discrete random variable, okay, because it has three possible outcomes that we can literally count. Okay, so we can count those outcomes. You can have zero females, one female, two females, okay, and also those three possible outcomes, that's a finite number of outcomes. Okay, so let's just review from lesson 10 what the procedure is in this particular example. So the procedure is we're looking at two births, and an example of an event would be something like what I have up here, a boy and then a girl. So I'll write it as B and G. And so now I want you to think about all the possible outcomes you can get in two births. So we're going to write down all the possible outcomes. That gives us our sample space. So we could have a boy first and then a girl, but then we could also have a girl first and then a boy. Or we could have a girl and then a girl, and then we can have a boy and then a boy. And those are really the only outcomes we can have in two births. So that means that we have a total of four possible outcomes. Now that we have the sample space, we can build a probability distribution. And there are two ways that you can create a probability distribution. You can create it as a table of values, or you can create a graph that we call a histogram. Now that we have our sample space, we can calculate the probability and then go ahead and make that probability distribution. So our probability distribution, and I'm going to create it as a table first. Okay, so if we take a look at our sample space, we can see here that to get zero females in two births, that would occur if we had the boy-boy situation. So what is the probability of us getting a boy first and then a boy second in two births? Well, that is only one out of four ways of having two births, okay? So that gives us 1 out of 4, or a probability of 0.25. Okay, now let's take a look at the different ways that we can get one female in two births. Well, that would happen if we had a situation where we had a boy first and then a girl, or a girl first then a boy, because in both of those situations, we have one female in two births. So that is a 2 out of 4, all right, chance of that happening. So that gives us a probability of 0.50. And then if we take a look at getting two females in two births, well, that happens only if we have girl girl. And the chances of getting girl girl, well, that's a 1 out of 4 chance, or a probability of 0.25. So now what we have here is we have our probability distribution for our random variable x. And then what we can do with this is turn it into a graph or a histogram. So here you can see that we have taken the table and just translated it into this histogram to show the probability distribution as a graph. Here, I also want to make sure that we stop and check to make sure that the three requirements are met for a probability distribution. So remember, the three requirements are that first, your random variable, it has to be numerical, and in this case it is, okay, because the random variable is the number of females in two births, so 0, 1, or 2 is numerical. It's also associated with a probability. So we have chances of getting, boy boy or boy girl or girl or girl boy. Right. The second requirement is that when we take a look at the individual probability for each possible outcome, right, and we add them up, when we add them up, the sum of all those individual probabilities, they have to add up to 1. And here we see that it does. Okay, so 0.25 plus 0.5 plus 0.25 does add up to 1. So that second one is met. So the first criterion is met, the second criterion is met. And then the third criterion is that each individual probability for each possible outcome is a value between 0 and 1. And here we can check that 0.25, 0.5, and 0.25 are all values between 0 and 1. So those three requirements have been met for the probability distribution.